This video is an example of finding a probability using the fundamental counting principle or permutations, and we're also going to be using the classical definition of probability. A box of jerseys for a pickup game of basketball contains 9 extra large jerseys, 7 large jerseys, and 4 medium jerseys. If you are first to the box and grab 3 jerseys, what is the probability that you randomly grab 3 extra large jerseys? Okay, the first thing we want to do, or the first thing I would do, is find the denominator. So the denominator is just going to be all the ways we can grab 3 jerseys without replacement, because it's not like you're grabbing a jersey, putting it back, grabbing a jersey, putting it back. Okay, so we need to first know how many jerseys we have altogether. So we have 9 extra large, 7 large, and 4 medium. So we have 20 total jerseys. 20 jerseys altogether. So the denominator is just going to be how many ways we can select 3 jerseys without replacement. So I could use the fundamental counting principle, or I like to abbreviate that as FCP. I've got jersey 1, jersey 2, jersey 3, and we're multiplying in between how many ways each event occurs. And the events here would be selecting a jersey. Okay, so the first selection, we've got 20 jerseys to select, possibilities, but we're not keeping the jerseys. So when we select the second jersey, there's only 19 left. And then again, without replacement, there's 18 left for jersey 3. Okay, so this is the denominator. Okay, so the probability that we get 3 extra large, okay, we have that denominator that's going to be 20 times 19 times 18. Now the numerator is just the situation where we get only extra large, and we want 3 of those. So we have 9 extra large jerseys. And again, we're sampling without replacement. So using the same reasoning, okay, so this up here would be the denominator. For the numerator, again, the numerator is always a subset of the denominator in probability. Okay, so contained in all of these possibilities is the case where we get exactly 9 extra large. So again, using the fundamental counting principle, I've got 3 jerseys, but this time they're only extra large. So jersey 1 XL, jersey 2 XL, and jersey 3 XL. And again, we're multiplying across. So because we only have 9 extra large jerseys, this first slot will be filled with 9, but again, we're sampling without replacement. So we have 8 extra large jerseys left, and then 7. So this right here will be the numerator. And the reason why I put parentheses around this is because if you're going to put this into your calculator, it's to your advantage to put parentheses around the numerator and the denominator, just so the calculator will appropriately observe order of operations. Okay, so doing that operation in the calculator, okay, I get 504 for the numerator, and 6,840 for the denominator, and converting that to a decimal and rounding to 4 decimal places, I get 0.0737, okay, rounding to 4 decimal places. Now, as I said in the beginning of this video, this is also a permutations problem. Okay, so going back up here, looking at this denominator, I have 20 total jerseys. This is a permutation right here. So this denominator can also be thought of as 20 permute 3. Okay, so alternatively, we could write this as 20 permute 3. And then looking at the numerator, this is also a permutation, and we're permuting 3 objects out of 9. So this will be 9 permute 3. So if I put this into my calculator, it's going to take a couple of steps. Try to make room here. Okay. All right, 9, and I go to my math menu, right arrow to probability. Option 2 is n permute r. Okay, so if I look at 9 permute 3, I get 504, which is the same numerator I got previously using the fundamental counting principle. And then the denominator expression is 20 permute 3. And again, you'll see that matches what I got when I reasoned through this using the fundamental counting principle. So you could either reduce this to a fraction in its lowest terms or convert it to decimal. And you definitely want to round a probability problem to 3 or more decimal places.